Hi, this is Tarik Rashid. Again, the second part of Shrike Optimization Algorithm. The first part was about theoretical part. We explained it in earlier video. And this second part, I'll go through the mathematical background of this algorithm and how we can, if we know the mathematical background and we know the algorithm, then we will be able to use the uh, practical example or use this algorithm for solving unlimited solutions, unlimited problems. So it's part two, and I'll talk about. I mean, you need to know the part one, and then you'll come to mathematical background. So in mathematical background, we have initialization phase, population and environment. Equation 2 will initialize the values for female parent and male parent. There's upper bound for every dimension, every variable, decision variable, lower bound and upper bound multiplied by random initialization, this is Metaheuristic, plus lower bound. Well, this is um, one-time initialization, and then we get a population, and then we ensure that all population within the upper bound and lower bound. If not, then we will cap them to become within the lower bound and upper bound. So equation 5, this is environmental influence factor R, which can be determined by this equation, Tmax and current iteration and total iteration. And then we will get uh, the R. Well, R for iterations or early iterations, larger R goes to exploration, global search, whereas smaller R goes to exploitation, local search. And this is good when we are in the feeding phase and we need this R to be plugged into equations in the feeding phase. Now, breeding phase, we have nestlings generation. So the breeding phase, this is before the initialization. This is before running the algorithm initialization. So we have the equation tree, egg displacement, delta egg, which is can be produced by the difference between female parent and male parent plus the R that we talked about it. And nestling generation, which is the solution, the paired, the solution or nestling, which is the female parent plus uh, the delta egg. Now, again, we talked about every K generation. We check whether uh, when the nest needs regeneration. So when we expand search, we try to take the elite solutions and we introduce those candidates, nestlings, whereby good ones, and we cannot keep or we reject those, they are not good. Now, feeding phase, exploitation mechanism, this is parent feeding himself. So a male parent feed himself. So the bird here represent the male parent multiplied by the R and to get the delta food. Okay, so this is local refinement of the best solution. So the best solution will try to improve itself. And we have male guided feeding, which is we have uh, for the nestling, the male will try to feed its child, bird, bird, and then plus the male. So that's the equation of male feeding for the nestling. And here the equation, similar equation, but with little changes. This is female guided feeding for its nestling. Okay, so that's the male one, that's the female one. When this one didn't produce a better solution, we try this one. Okay, and here the update phase, position adjustment. So position adjustment means that the bed, uh, next bed solution equals the current bed plus um, the the delta food. Um, and this is uh, we use 6 to 8, the equation 6 to 8. One of them for male, and the other one is parent feeding the child, and the last one female parent feeding its child. So just I go through so that you don't get any confusion here. This is um, uh, male parent feeding himself. This is male parent feeding its child, and this is female parent feeding its child. And this is the new solution equals the current solution plus the delta food, which can be, this delta food can be obtained from 6, 7, 8, depends on the situation. Now, if we couldn't find a good solution, okay, if the solution it's worsening, so we try to make a leap or jump to get out of the local search and come to exploration, global search. This equation will help us to get into global search, okay? And if the fitness of the um, new solution is not good, then we can keep it. If it's good, we keep it. So this is a summary of the equations that we said. Initialization and using natural factor, equation 5, and generate the kids or nestlings, and then uh, parent feeding for himself, male parent male feeding nestling, and female parent feeding nestling. And then equation 9, update of the to get the new bird. And then if it's not good, then we have equation 10. I think that's done all mathematical models for the SHOA algorithm. If you have any problem, please uh, refer to the original paper or email me on my email address. Thank you very much and stay tuned. And we have the next part, the last part of SHOA is showing you practical examples, step by step, how this algorithm can be implemented and how it can be used for unlimited problems. Thank you very much. Stay tuned.